Question number 26 asks us to compare the radius of a chlorine atom to that of a chlorine ion. Now, a chlorine atom has an electron configuration of 287, but a chlorine ion has a charge of a -1. That means it gains 1 electron. So here, when we sum these electrons together, we get the electron configuration of 288. Whenever you gain anything, you always get larger. Question number 27 asks, which atom has the greatest tendency to attract electrons? Remember that this definition is that of electronegativity. So we'll simply look at reference table S. We can see electronegativity is found here. Barium, element number 56, has an electronegativity of 0.9. Beryllium, found here, element number 4, has an electronegativity of 1.6. Boron, element number 5, has an electronegativity of 2.0. And bromine, as we scroll down to element number 35, has a electronegativity of 3.0. Here we are looking for the greatest or largest tendency to gain electrons, so bromine would be the best choice. Next we're asked which of these would have the smallest radius. Fluorine has a electron configuration of 2,7, but fluorine ion gains 1 electron, giving it an electron configuration of 2,8. Chlorine has an electron configuration of 2,8,7, but its ion gains 1 electron, becomes 2,8,8. Potassium has an electron configuration of 2,8,8,1, but its ion loses an electron, and when it loses its electron configuration becomes 2,8,8. And calcium has an electron configuration of 2,8,8,2, but when it forms an ion, it loses 2 electrons, and it has the electron configuration of 2,8,8. So here, the smallest electron configuration is that of fluorine. Question number 29 asks, which electron dot diagram represents the given element? Remember that electron dot diagrams only represent the valence electrons. Sulfur should have 6 valence electrons. Since this sulfur has 4 dots, it is not correct. Lithium has an electron configuration of 2-1, so it should only have 1 valence electron. Aluminum has an electron configuration of 2,8,3, so it should have 3 valence electrons. This has 3 valence. And boron has an electron configuration of 2-3, so it should only have 3 valence electrons. So this is incorrect. The next question asks why a lithium atom is larger than a lithium ion. So lithium is element number 3. Lithium has an ion of a +1 charge, meaning its ion loses an electron. So lithium is a metal, and it loses an electron to form an ion. Next, we're asked to draw the Lewis dot structure of a calcium atom. Calcium, from our reference table, is element number 20, has an electron configuration of 2,8,8,2. So a calcium atom will have 2 dots. So its Lewis dot structure will look like this. Next, it asks to draw a Lewis dot structure of an atom of chlorine. Chlorine has an atomic number of 17. Its electron configuration is 2, 8, 7. So it'll have 7 dots. Chlorine's electron configuration looks like this, Watch my dotting pattern. 1, 2, 3, 4, 5, 6, 7. Notice I go in a circular pattern one at a time. And lastly, it asks to draw the Lewis dot structure for calcium chloride. Now, calcium is a metal, and chlorine is a nonmetal, so they will form an ionic bond. When drawing the Lewis dot structure of an ionic bond, what you'll first do is you'll draw the Lewis dot structure of the positive ion, and it will have no dots, as it will have lost all of its electrons and donated them to the negative ion. So chlorine originally has 7 dots. 1, 2, 3, 4, 5, 6, 7, but it desires 8, so we'll have gained 1 from calcium. Now this is not the complete Lewis dot structure, because calcium has a charge of +2. If it combines with a chlorine of a -1, it does not have an overall 0 charge, so it will require 1 additional chlorine. So we'll draw an additional chlorine with 7 dots. 1, 2, 3, 4, 5, 6, 7, and its 8th dot comes from calcium. Now notice that the sum of the charges, -1 plus +2 plus -1, sum to 0. For question number 34, we were asked to first draw the Lewis dot structure of an ammonia molecule. When drawing the Lewis dot structure of a molecule, the word molecule means covalent, and covalent means sharing electrons. First, we must identify the central atom. The central atom is always the atom without a subscript. Here, nitrogen has no subscript, so it is the center. Nitrogen has 5 valence electrons. So we will draw the symbol nitrogen with 5 dots. Again, 1 dot per directional coordinate in a circular pattern. 1, 2, 3, 4, 5. Bonds can only form where there are unpaired electrons. So one bond will form here to a hydrogen. Another bond will form here. The last bond will form here. Hydrogen only has 1 valence electron, which is represented by the bond. So here we have 1, 2, 1, and 1. So this is the Lewis dot structure of ammonia. Question number 34b asks why carbon tetrachloride is a nonpolar molecule. Now this will not be on the test, though we'll review it now. Nonpolar molecules are a result of symmetrical or even charge distribution. Question number 34c, or a similar one like it, will be tested on your bonding exam. It asks, explain how the bonding of potassium chloride is different than the bonding of the molecules of A, B, and C. Here they give us the key word molecules. Molecules means covalent. Now potassium chloride contains potassium, a metal, and chlorine, a nonmetal. It is ionic. So here, the biggest difference is potassium chloride has ionic bonds, while the molecules have covalent. For question number 35, we will draw the Lewis dot structures for all of the structures. We'll begin with the ionic compound calcium oxide. Recall that ionic compounds transfer their electrons. So we'll begin with the symbols for calcium and oxygen. Calcium will transfer its electrons to oxygen, as calcium has a +2 charge and oxygen has a -2 charge. Oxygen's typical valence is 6. 1, 2, 3, 4, 5, 6, but it gains 2 electrons from calcium. We always place our negative ion in brackets to show that it has gained electrons. Hydrogen bromide. Both hydrogen and bromine are nonmetals, making it a covalent bond. Here we have hydrogen, which has one valence electron, and it will bond with bromine. Now bromine has 7 valence electrons. They are going to share electrons with hydrogen. So here we'll complete its valence, beginning with the bond formed. 1, 2, 3, 4, jump the line, 5, 6, 7. Lastly, we have carbon dioxide. Carbon dioxide has the chemical formula CO2. Recall that the central atom is always the atom that does not have a subscript. That would be carbon. Carbon's valence is 4. 1, 2, 3, 4. The bonds of your peripheral atoms must be as far apart as possible. If I place one bond here to attach the first oxygen, I'll have to place the other bond exactly opposite here. I will not choose to place the oxygens on these spots because they are not as far apart as possible. Now, if there was a different central atom and there were electrons in pairs, bonds could not form there. Now, oxygen has a valence of 6. Completing the valence, starting at the bond, we have 1, 2, 3, 4, 5, 6. And then on the next oxygen, we have 1, 2, 3, 4, 5, 6. Notice that there are some unpaired electrons. So what's going to happen is these unpaired electrons will combine to form a multiple bond. So if we neaten up our structure, in a box above, we'll show you what carbon dioxide looks like. So the carbon has double bonds to the oxygen. And if we simply place the remaining lone pair unbonded electrons, they'll look like this. Now what you'll see that is the most accurate is that a lot of times the electrons in the bonds will arrange themselves as far apart as possible, so they are completely repelling. So you may notice that the arrangement will look a little bit more like this in a textbook. Now, this technique is perfectly acceptable, though the Regents will allow you to have something like the structure above. So this is perfectly okay. This is best. The next question asks us about a nonpolar molecule. Now, these will not be tested on our bonding exams, but we can review it. Nonpolar molecules have symmetrical charge distribution. They must be perfectly symmetrical or have a final subscript of an even number. Hydrochloric acid's final subscript is 1. Water's final subscript is 1. Ammonia's is 3. And carbon tetrafluoride's is 4. So this is a nonpolar molecule. Question number 37 asks, which atom, when bonded as shown, has the same electron configuration as argon? Well, referring to our reference table, argon, element number 18, has electron configuration of 2, 8, 8. So the atom that would have an electron configuration of 288 would be sulfur. And that is because sulfur's electron configuration is 286, but it carries a charge of -2. If we sum these together, it will have a electron configuration of 288. So carbon dioxide is nonpolar because it has a symmetrical distribution of charge. Now, the carbon-oxygen bond is more polar than the fluorine-fluorine bond because the electronegativity difference between carbon and oxygen is 3.4 minus 2.6, or that would be 0.8, versus the electronegativity difference of fluorine would be 0. This concludes the review for the exam on bonding. It will be a multiple choice only exam. Please remember to review your high marks Regents Chemistry Review book. I will post the answers on the next slide. Pause for page 1. Pause for page 2. Do not forget to review formula writing and naming compounds. You'll have to use the stock system and correctly name ionic and covalent compounds.